Alright, example 13.3. Calculate the maximum permissible speed for the curve of the higher of the broad gauge group of the road with the following particular degree. The degree of the curve 1 degree super elevation at 80 millimeters, length of the transition curve 120 meters, maximum likely sanctioned speed 160 kilometers an hour. The radius of the curve is 170 divided by the d, with 150 divided by 1, 175 meters. 1750 meter with the speed, safe speed over the curve of the theoretical consideration being with the high speed velocity of 0.27 over the square root of the Kant efficiency and Kant deficiency plus the Kant deficiency, Kant and plus Kant deficiency divided by the radians. Kant is equal to, maximum is equal to 100 millimeters. Assume that the Kant efficiency is 80, the radius is 1750. Velocity is 0.275. The square root of 800 plus 100 times 1750 is 151 kilometers an hour. Speed based on transition length of the Kant gain of the Kant not exceeding 55 millimeters a second. The velocity of meters times 198 L divided by E is 198 times 198 times 120 divided by 8,297 kilometers an hour. Rate of the gain of the Kant cannot exceed 55 millimeters a second. Velocity of meter of the 198 L times Kant deficiency 198 times 120 divided by 100 is 2376 kilometers an hour. Kant gradient 1 inch times 120 times 100 millimeters times 80 millimeters 1 in 1500. Maximum permissible speed is at least allowing the maximum suspension speed of the section of 160 kilometers an hour. Safe speed with the theoretical consideration of 1.3 kilometers an hour. Speed say based on transition like 237.6 kilometers an hour. Therefore, the maximum speed over the curve is 151.3 kilometers an hour or 150 kilometers an hour. Controlling factor for the case of the safe speed with the theoretical consideration, not rate of the change of the Kant deficiency. How though no further analysis necessary. Example 13.4. Calculate the maximum permissible speed of the 1 degree curve of the Rajan route with the maximum speed section of 130 kilometers an hour. Super elevation provided 50 millimeters. The transition length with the 60 meters. The transition length with the curve cannot be exceeded. Increase due to the proximity of the yard. The radius for the curve is 175 divided by d with 175 divided by 150 meters. Speed of the curve of the theoretical consideration velocity equals 0.27 divided by square root of Kant x. Kant is, again, Kant deficiency times r with the Kant is equal to 50 millimeters. Kant maximum Kant is 100 millimeters. Radius is 150 millimeters. 150 equals 1750 millimeters. Velocity is 0.25. Square root of 500 plus 100 times 1750 is equal to 138.3 kilometers an hour. Speed based on the transition rate length, the rate of the change of the Kant not exceeding 55 millimeters a second. Velocity in meters 198 in length with the Kant deficiency with equal to 198 times 60 the over 50, 237.6 kilometers an hour. Rate of the change of the Kant deficiency 1955 millimeters a second. Velocity in meters 198 length with the Kant deficiency 198 Kant maximum 198 times 60 divided by 100, 118.8 kilometers an hour. Kant gradient 60 times 1000 millimeters equal divided by 50 millimeters is 1 in 1200. The maximum sanction speed with the curve is at least the following. Maximum sanction speed section 130 kilometers an hour. Safe speed with the theoretical condition 138.83 kilometers an hour. Speed transition is 118.3 kilometers an hour. In case of the speed restricted with 118.8 kilometers, the basic constraint with the transition like the Kant deficiency of a per of 100 millimeters is assumed, which is maximum possible value with the other field. The Kant deficiencies make somewhat lower the given lower rate of change of the Kant deficiency given the transition length with a higher permissible speed. Optimum value of maximum permissible speed found with the following equation: equilibrium super elevation equals actual Kant plus Kant deficiency for the maximum permissible speed with the given transition length, or gauge velocity squared divided by 127 r equals actual Kant plus 198 of the length of given permissible speed divided by the velocity, or g is equal to 1750 times the radius of 1750 meters, the length of the 60 meters, the velocity maximum speed, permissible speed, therefore 1750 velocity squared times 127 times 11750 equals 50 over 198 equal times 60 over the velocity. Solving this equation, velocity of 133 kilometers an hour, the value of the however cannot be more than the MSS connection section of the 130 kilometers an hour. Therefore, the maximum permissible speed of the curve is 130 kilometers an hour. Velocity of 130 kilometers an hour. The cant deficiency 198 times the length divided by the velocity 198 time equals 198 times 60 divided by 130, which is less than 100 millimeters, at which the maximum speed over the circular curve is 130 kilometers an hour. If the transition curve is 118 kilometers an hour. Broad gauge line with the take for the contrary flex through the 112 turnout main gauge light track with the 3 curve due to the turnout the maximal permissible the branch line 30 kilometers an hour. Calculate the negative super elevation provided with the branch line to the maximum permissible speed of the main line track, which takes off the straight track. From the branch line track, the degree of the curve is 3 times 1 equals 1 degree radius of 1750 divided by d with the 17 to 1 divided by 1 is 1750 meters. The equilibrium super elevation is the gauge times the velocity squared divided by the 127 times the radius equals 1676 times the 30 squared over 127 times 1750 is equal to 6.8 meters. After rounding the higher hit multiple to 5, it is taken the 110 millimeters value of navigation, the negative super elevation branch line track of the x equals e super elevation to minus the cant deficiency are equal to 10 millimeters times minus 75 millimeters, 65 millimeters negative. Super elevation for the mainline track, the 65 millimeters is the same as the super elevation branch line track, but opposite the direction. The maximum permissible speed with the calculated taking actual super elevation mainline track, 65 adding to the cant deficiency 75, then using the super elevation of the 100 millimeter of the 65, 75 plus 75 of that formula equilibrium speed. Mainline track has 3-degree curve with the 1750 divided by 3 is 583.3 meter radius. Therefore, the maximum permissible speed of the mainline track is equilibrium super elevation gauge times velocity squared divided by 127 r with equal to 1676 times the velocity squared times 127 583.3 equal to 140 millimeters. Or velocity square root of 127 times 583.3 times 100 times 1676 is 778.7 kilometers an hour. Alternative maximum speed can also be calculated as follows. Velocity equals 127 times square root of the actual and cat plus cant deficiency times the radius is 0.27 times square root of 65 plus 75 times 385 77.16 kilometers an hour. Therefore, the maximum permissible speed of the mainline track is 77.16 kilometers an hour. After running the lower multiple of 5, it becomes 75 kilometers an hour. Alright, your transition curve. That is the train commences with the motion of the circular curve of the straight line track that's projected with the central figure forces which may not cover the discomfort of the passengers, but also distort with the track alignment, the effect of the stability with the rolling stock, or to smooth out the shift of the train line with the curve of the transition curve of the curve provided with either side of the circular curve so that the central figure of the build with the gradually super elevation flow runs out of the uniform rate. Transition curve, therefore, is the curve of the uncomfortable ride with the degree of the curvature of the gain with the super elevation uniform with their length, starting with the zero tangent with a specified value with a circular value following the objective of the transition curve, the degree of the radius of the curvature gradually planed away, infinitely straight line specified with the value of the radius for the curve in order to help the vehicle negotiate the curve smoothly. To provide gradual increase with the super elevation starting with the zero of the straight line with the desired super elevation circular curve that ensure the gradual increase of the degree of central figures so enable the vehicle to negotiate curve smoothly. 310 shows the transition curve straight, the transition curve, the x and py angle, and our regular curve. 13.4.1 Regular requirements for the ideal transition curve. The transition curve should be satisfied with the following conditions. It should be tangential. Should be a tangential with the straight line with the track, and should start with the straight part of the track with the zero curvature. But it should join the circular tangentially, and should finally have the same curvature as the circular curve. The curvature should increase with the same of the rate of the super elevation. Length of the transition should be equal to the attained the final super elevation, increasing gradually specified rate. 13.4.2 The type of the transition curve. The type of the transition curve is theoretically provided with described in the shape of the least curve that figured in 13.11. Different type of the transition curves. 45.45 A and P angle of 30 Burns eye lemniscal curve major axle spiral spine curve parabola. Real spiral, the ideal transition curve is not due to the mathematical complication equation. Equal spiral is equal to the degree times equal to the length squared times the r times r e divided by 2rl. Cubical square spiral. This is also a good transition, quite difficult to set on the field. Y is equal to length squared divided by 6rl. Briel's lemniscate curve with its radius described the length of an increase because of the rate of the acceleration, keeping the fall with however not uniform beyond 30-degree deflection angle. The curve is not used on railways. Or your cubic parabola of the Indian railways mostly use the cubic parabola for the transition, for the curve of the equilibrium, cubic parabola, and the curve of the curvature of the cant increase with the linear rate of the cant, with the transition curve of the straight, with the curve of the range flow, the interconnection of the same level throughout a rail with the range with the linear throughout the length of the curve of the straight line, the ramp with the provide with the touch for the transition train, the notations equation 1315 is filed with the angle between the straight line track of the transition curve. The L is the distance. Any point of the transition curve the taking off of the point. A large L is the length of the transition curve. The X is the transition horizontal condition of the curve. Y is the vertical coordination of the transition curve. R is the radius of the circular curve. S is the S-shaped transition curve. The S-shaped transition curve, the curvature of the super elevation assumed with the shape of the two quadratic parabolas inside with the straight line ramp. The S-shaped parabola ramp is provided with the transition curve. The special feature of the curve that shift is required. Shift is expanded with the following section. In this case, only half the normal shift is provided with the straight line ramp. The value of shift is S equals L, large L squared, time divided by 48, or with further gradient centered with the twice the sleeper curve with the straight line line ramp. The curve the desired with the special condition for the shift is restricted due to the side with the condition. The railboard is decided Indian railroads transition curves will normally be laid in shape of the cubic parabola. Alright, 343, the shift. The main circular curve of the fissure of the transition will lay with the shape of the cubic parabola required for the move of the inward measure normally as the shift, known as the shift. The value of the shift is collected with calculated using the formula S equals L squared divided by 24. S is the shift, L is the length of the transition of the curve in meters, R is the radius in meters. The offset of the straight line is at any point of the transition curve is calculated using the equation. Y is equal to 16.7 times x squared divided by LR. Y is the offset of the straight line in centimeters. The x is distance from the commencement of the curve, and L is the length of the transition in meters. R is the radius of the curve in the meters. Okay, 344, length of the transition curve. The length of the transition curve prescribed in the Indian Railways maximum of the following 3 degrees. The length of the transition in meter of the time equals 108,000 times the cant actual times the velocity meters equals cant actual times cant deficiency divided by 125 equal to 72 hundredths of the cant actual. Length of the curve of the cant actual, cant, and the super elevation of the cant deficiency in millimeters. Alright, formulate 13, 19, 13, 20 base for the rate of the change of the cant deficiency for 13, 5 millimeters. Formula 13, 21 base the maximum cant creating with a 1 in 720 with a 1.4 millimeters in a meter. Other provisions made with the requirements of special situation are followed with the design length with the transition curve, particularly on the high-speed route with future speeds exceed with the implemented with the track such as the 160 kilometers an hour Group A route with the 130 kilometers the Group B routes may be taken into account. An exceptional case for the no space is available providing with the full length of the transition curve, particularly with the high-speed route with the preceding with the calculation length of the transition curve that may be reduced to 2/3 for the desired length of the workout by equation 13, 19, 13, 20. This is based on the assumption of the rate of the change of the cant and the cant deficiency exceeding 55 millimeters section. The maximum cant gradient will not be the steeper than 1 in 368 or 2.8 millimeters a meter. Relaxing permitted with the broad gauge only in the broad gauge section for the meter in the narrow gauge. However, they cant gradient should not be steeper than 1 in 720 or 1.4 millimeters an hour. For the meter gauge, the change of the cant and cant deficiency should not exceed 35 millimeters a second. As location length of the transition curve, the restricted as such the inadequate permitted this maximum speed calculated with the circular curve. The design should not be located. There should be such that the cant and the cant deficiency are loaded with reduce the maximum speed of the transition curve to permit the high speed of the curve as a whole. Alright, 13.6 for the curve of the 600 meter rate for the broad gauge section that is limited to transition of 40 meter length. The calculating the maximum speed for the permissible super elevation, same maximum sectional speed, or MSS, is 100 kilometers an hour. An additional maximum normal situation 600 meter radius will quite along with the transition curve of the maximum sectional speed of 100 kilometers an hour. However, the transition curve that has restricted to 40 meters of the cant can also be selected with the speed of the main curve, the circular curve that equal to the speed of the transition curve as a whole. For the circular curve, the maximum speed is equal to the equation 1310. The velocity of 0.27 is equal to the radius times the cant actual plus cant deficiency square root. The most favorable speed of the cant actual equals the cant deficiency. The transition curve of the maximal change of the cant is equal to 55 millimeters a second. The maximum speed is calculated as its length times the cant actual divided times the velocity in meters equal to 198 of the velocity is equal to 198 length times the cant actual. Therefore, 0.27 is the square root of r times c cant actual plus cant deficiency equals 198 lc cant actual. 127 of the radius, square root of the radius, 600 plus 2 cant actual equals 198 with the 40 divided by cant actual. On solving the equations, the cant actual at 89.50 millimeters or 90 millimeters. Upper limiting value, the cant deficiency is 75 millimeters. Maximum speed 0.27 of the square root of the radius of times the cant actual plus cant deficiency, or 84.95, approximately 85 kilometers an hour. Cant grade of 90 millimeters divided by 40 times 1,000 is equal to 1 in 444, which is permissible foundations of 1 in 366. Therefore, the maximum permissible speed at 85 kilometers an hour super elevation provided with 90 millimeters. Alright, 13.45, laying of the transition curve. The transition curve laid with the following steps in figure 13.13. You see the length of the transition curve, the shift 1, 2, 3, 4, 5, 6, 7, 8, and then the transition, the length of the transition curve, the cubic parabola from y2, 1, y1, y2, y3, y4. The shift 2 and shift 1, y5, y6, y7 junction with a circular curve. Length of the transition curve with the formula given in the equation 13.9 and 13.21. The transition length with divided in equal numbers of equal parts, usually 8. The equation of the cubic parabola shift the equation 13.15, 13.17 reproduced there are actual calculations. Y is equal x cubed divided by 6r7 over the 0.176. X cubed divided by RL, or S is equal to length squared divided by 24R, or 0.42 times length squared divided by R. All measurements same units. The shift is calculated using the formula 2 with the ordination for the calculated 1, 2, 3, and etc. They use the following formula: y1, y2, y1 L8 the square the cube the 6RL S equals 128. Y is equal to L divided by 4 cubed over 6RL S 16. Y third is 3L M divided by 8 squared cubed 6 divided by 6RL 0.2211 S. Y4 is L divided by 2 the cubed the 6RL 0.500 thousandths S. Y5 is 511 divided by 8 cubed, the 6RL is 0.976 S. Y6 is the 6L divided by 8 cubed, the 6RL, and 168 S. Y7 is 7L 8 divided by 8. G 6RLS 268 S. YL3 is divided by 6RL is 4S. At the point where the transition curve of the determinant approximately shift the existing tangent points because the distance equal to half the length of the transition curve. The opposites y1, y2, y3 are measured perpendicular to the tangent to keep the profile of the transition curve. The 13.5 compound curve. Compound curve is formed with a combination two circular curve. The different recurving radii curve in the same direction. The common transition curve may be provided between the two circular curves. Compound curve, assuming that such for the connection of the curve that's transferred the uniform speed of length of the transition curve. In addition, two circular curves can be obtained with the following: length equals 8 thousandths of the cant efficiency 1 cant 1 cant 2 times as or whenever the greater of cant A and cant A1 and cant D1 are the same cant and cant deficiency for the curve and curve 1 and curve A2 and curve D2 are the cant deficiency for the curve of the 2 millimeters length of the transition of the curve. L is the strength of the transition curve in meters, and Vm is the maximum permissible speed in kilometers an hour. 13.14. The compound curve shows the tangent 1, tangent 2, S1, S2, X1, X2, X3, OT, reverse curve is formed with a combination of two circular curves. Opposite curvature of the common transition curve may be provided between the two circular curve. The reverse curve, the two length of the transition curve of the common circular curve. The individual circular curve may be obtained the same, and they are explained. The compound curve is section 1375. This shows the center O1, center O, and center O2. The tangent between A and B, radius 1 and radius 2, and the radius is from tangent 1, B, center of the O2, from tangent 1 to tangent 1, tangent center of the O1, radius 1, 3, and radius 3 and 3, tangent 2 and 3, T3 and T3. That is a reverse curve. It has been stipulated with a high-speed group with the AB route, the minimum straight length with the 15 meters should be kept in between the two curves containing the reverse curve. In the case of high-speed meter gauge, the distance with kept should be 30 meters. The straight line between the circle of the curve between less than 50 meters for the gauge section group. The AB route less than 30 millimeters high meter gauge route should be eliminated. Suitability extending with the transition length. When doing so, should be ensured with the rate of the change with the cant reversal line along with the two transition length with the extending within the kept the same when such the straight lines between the reverse curves cannot be eliminated. The lengths can be increased to be over 50 millimeters in case the broad gauge, 30 meters for the case of the meter gauge. Speed of success for the 130 kilometers broad gauge and 100 kilometer an hour meter gauge should not be permitted. Alright, 137 extra clearance for the curve. Extra clearance are provided with a horizontal curve with the keeping the following with a consideration in mind. If active with the curvature vehicle to negotiate horizontal came, the frame does not follow the path with the curvature if the rigid structure is unable to bend. Vehicles therefore project towards the inside of the curve central point with the toward the outside of the curve near its end of the longitudinal axis of the body vehicle movement. The center line of the track is extra clearance required. 1316. 13.6 effective curvature of the long vehicle end of the throw A and P of the Q is the end of the throw F and E of the overthrow. The C is the length from A C and L. Alright, the extra clearance is required for the center of the vehicle to which project the toward the inside of the curve golf of the overthrow is given with the equation EF equals C squared divided by 8R. The extra clearance required for the end of the vehicles projected toward the outside of the curve golf of the end of the throw given by the equation AP or BQ is equal to L squared times minus C squared divided by R8. 8R, length of the vehicle, C of the center of the distance between the bogies, R of the radius of the curve. Effective leaning due to the super elevation. Account of the super elevation provided by the curve of the vehicles leaning toward the inside of the curve, thereby running the extra clearance. The figure in 13.7 the extra clearance is required with the length leaning as follows. You gotta go with me. Alright. Leaning as follows: HEG, the height of the vehicle, and E, the super elevation, G is the gauge.